Now we will do examples. So examples for Cauchy Riemann. Okay. So we show that f of z squared equal to this, and this is u and v. We show that indeed this satisfies Cauchy Riemann. Okay, so u of x is 2x, and u of y is minus 2y, v of x is 2y, and v of y is 2x. And so indeed, we get the Cauchy Riemann equations. So satisfy CR. And the second question is find the level curves. So we have u equal to constant, v equal to constant. So x squared minus y squared is constant, and 2xy is constant. So let me draw the picture. So these guys are hyperbolas. Like this. So this is what is it? Real part of f is constant, and these are 1 over x functions. I should use different color. So imaginary of f equal to v is a constant. Okay, so that's an example. Okay. Right. So question, is f of xy equal to z bar squared is this guy analytic, C differentiable? So is it right? Is it analytic? Okay, let's see. Well, first let's compute the Cauchy Riemann. So let me do this. This is plus I with a minus. Okay, so u of x is the same as above. And then v of x is minus 2y. V of y is minus 2x. Okay, so if x is not 0, so if x is not 0, u of x is not equal to v of y. So CR fails on x-axis. And same for this case, so uy is not minus vx, so CR fails on y-axis. So sorry, yeah, so how do you say it? Yeah, so CR fails for all x not 0, for all y not 0. So we only have CR at x comma y equal to 0, 0. Okay. Right. So f is not analytic for all x comma y not 0. So this or this. We only have analyticity at the origin. So nowhere else. Okay. And okay, so now let's go into harmonic functions. Okay, so what is that? A function u of xy is harmonic if the Laplacian is equal to 0. And what's the Laplacian? This is the second derivative of u plus the second derivative in y. Okay, so that's the definition of harmonic. Quick proposition, if uv satisfy Cauchy Riemann, then delta u is 0 and delta v is also 0. So why is that? Let's see. U double x, u double y. Well, what is that? U of x and u of y. Let's use Cauchy Riemann. So this is Vy, and this is Vx, but with a minus. Okay, so we have Vyx minus Vxy, and from 291, we'll learn that you can swap derivatives. And so you get 0. And the same is true for v. Okay. All right, so let's play with these functions. Okay, so very often we have a real function, real valued function, and we want to form a analytic function whose real part is the given function. Okay. one application is what we talked about before about stream flow. So applications. One is the stream flow. Another one is that level sets of U equals C and V equals C are orthogonal. And that's also very useful in application. So you have some level sets and you want to compute the perpendicular level set. So these are two applications. V is called the harmonic conjugate of U. Okay, so we have time for one example. Let me do it. So here we find the harmonic conjugate of log of x squared plus y squared. Okay. So we will use a Cauchy Riemann. We have u of x is derivative of log x squared y squared. So we have by chain rule this ratio and same x squared y squared 2y. Okay. Now by Cauchy Riemann, we know that this is v of y and this is minus v of x. Okay, so let's integrate star. So we have v is equal to what? 2x x squared plus y squared, but in what variable? dy, because we integrate in y to get v. And remember your constant, but this constant will be a function of x. So function of x, because when we take y derivative, it disappears, right? So h d dy of h of x is 0. So if we want to go from a derivative expression to integration, we have to include the x constant. Okay, so let me do the integration. This is just the arc10, so, right? So we have 2 times arc10 of y over x. So recall, arc10 of x over a, derivative in x is a squared plus x squared in a. And then plus h of x. Good. All right. But we still need to find h of x. So we use the second, CR equation. So we have minus vx is equal to what? Or let me write like this. So vx is minus 2y x squared plus y squared plus h prime of x. But from this guy, we have the following. Minus 2y x squared plus y squared. Okay, so these two cancel out, and we get that h prime of x is constant. So h prime of x is 0, so h of x is c. So it doesn't depend on anything, it's just a number. Okay, therefore b is 2 arctan y over x plus constant, and the function will be let's say we make a choice, so we make c to be 0, because there's infinitely many choices, so we have to pick one. No, we have to, but in applications, yes, we pick one. Okay, so that's the one, and in fact, you've seen this before. So let me take out the 2. So this is square root. So this is nothing else but logarithm. So that's why we also had the constant. In fact, let me keep the constant because that's the definition for complex log. Okay. All right. So that's it with examples for Cauchy Riemann.